Hi, welcome to Lesson 2, Matrices and Operators. As we pointed out in Lesson 1, MATLAB is designed not only to make it easy to program a computer, but also to make it easy to solve numerical problems. Numerical problems often involve operating on matrices, and MATLAB makes that easy. We're going to start this lesson by finding out what matrices are. Matrices, which is the plural of the word matrix, are special kinds of arrays. So what are they? Well, both concepts are pretty simple, really. First of all, an array is just a set of numbers arranged in a rectangular pattern. So imagine a piece of paper with rows of numbers written on it, like this one. This is a two-dimensional array. Numbers are called elements of the array, and each row must have the same number of elements as each of the other rows. In this case, we have 6 rows of 4 elements. We call this a 6 by 4 array. As you can see, it has 6 rows and 4 columns. And we always say the number of rows before we say the number of columns. Now imagine having a stack of 2 such pages, each with the same dimensions, but not necessarily the same numbers. We'll use the same two-dimensional array that we started with for one page, and we add a second page with the same layout as the first one, that is 6 rows and 4 columns. Now we have a three-dimensional array. Its dimensions are 6 by 4 by 2, which means 6 rows, 4 columns, and 2 pages. We always say the number of pages after the number of columns, just as we always say the number of columns after the number of rows. Now let's add a third page with the same layout as each of the other 2 pages. This is still a three-dimensional array. We've just changed the dimensions. This one is 6 by 4 by 3, which means 6 rows, 4 columns, and 3 pages. Arrays of 4 dimensions and higher are rare. We won't use them in this course. And the most common are the two-dimensional arrays. In fact, they're so common they have a special name. A two-dimensional array is also called a matrix, and that's what we call it. And if there's only one row in the matrix or only one column, in other words, it's only one-dimensional, the matrix is also called a vector. The most ingenious part of MATLAB is the way Moeller set it up to deal with matrices, and because of the special role that matrices play in MATLAB, he gave his language a name that stands for Matrix Laboratory. Okay, let's look at some matrices in MATLAB. Before we look at a matrix, let's remember what we did in Lesson 1 when we were doing plotting. We actually made a vector called x values, and we did it this way. We used a left and right bracket to mean that we wanted a vector, in this case of 3 values. We're going to use those same brackets to make a two-dimensional array, and here's how we'll do it. I'm going to use capital X this time. Here's my left bracket, 0, 1, minus 1. This time I'm going to put a semicolon. That means end of a row. I want to put another row. It has to have the same number of elements. Pi 100, right bracket means the end of the matrix. And what we see here is we have a 2 by 3 matrix. First row is 0, 1, minus 1. Second row is 2.5, 3.1416, and 100. Let me say a word about the 3.1416. We actually typed pi here, and as you probably guessed, pi means the ratio of the circumference of a circle to its diameter. You might think that pi is some kind of built-in variable. It's not. It's a built-in function. As you'll remember from Lesson 1, a function is just an operation that's invoked by giving its name. And we had examples there of clear, plot, title, axis. These were functions that did things to the screen. Pi is a little different. What it does is return a value, the ratio of the circumference to the diameter of a circle. It actually returns a lot more decimals than we're seeing here. The format we have set up only shows 1, 2, 3, 4, 5 digits, as you can see. So pi returns a value. And when we say it returns a value, we simply mean that the program inserts the value where the function name appears. As you can see, function name appeared in the middle of the second row, and so the value appears in the middle of the second row. MATLAB provides hundreds of built-in functions. Here's one called squirt. It actually means square root. MATLAB loves short names. And you can see when we hit return that we get the value 1.4142, which is the square root of 2. Of course, both of these numbers, pi and square root, are irrational numbers, so these digits would go on forever. MATLAB stores about 15 of them, and it's showing you just a few. Here's another function, sine of 30. Sine, like square root, takes an input value. Pi takes no input value. Some functions do, some don't. You might think this is sine of 30 degrees. It's actually the sine of 30 radians. If you want the sine of 30 degrees, you can do it this way. Sine d looks like send, and that's the sine of 30 degrees. Here's another function, size. I'm going to give it an argument, x. It says 2, 3. What this means is x is a 2 by 3 matrix. The job of size in life is simply to give the dimensions of the matrix that you give it in parentheses. Let's try this with another value. Let's make x equal 5. And let's do the size of x. Now, x is just a simple number, and since size is supposed to give you the dimensions of a matrix, and x clearly is not a matrix, it's probably going to give an error, one of those red messages. Well, no, it doesn't. In fact, it gives us that x has the dimensions 1 by 1. And here we see that MATLAB looks at everything as a matrix. This is one of the ingenious ideas that Cleve Moeller had to begin with MATLAB. A scalar is simply a 1 by 1 matrix in the eyes of MATLAB. You notice that we used a lowercase x for this 1 by 1 matrix. It's commonly called in mathematics a scalar, and it's common to use lowercase as the initial value or initial letter in the name of a vector, as we can see from x values up here at the top of the screen, and x, as we did here for the scalar. And we used a capital X for a two-dimensional array. MATLAB knows nothing about that. It's just a custom. You might say, maybe we want an array of voltages. Let's give it 1, 2, 3, 4, 5, 6. I'm in a hurry. I don't want to come up with any fancy values. So there's a 3 by 3 array of voltages. If we wanted to say what the first row was, we might say row 1, and I'll use an underscore to make this clear, of voltages equals, well, 1, 2, 3. And I used a lowercase r because this is, after all, a vector. Well, let's look at a vector a little bit more closely. Let's set x equal to 1, 4, 7. This is a row vector. Let's look at a column vector. I'm going to set y equal to 1 semicolon 4 semicolon 7. Since semicolon means the end of a row, we've got a row of only one element, another row of only one element, and a third row of only one element. And as you can see, row 1 is one element, 4 on the second row, 7. So this is a column vector, and MATLAB lays it out as a column vector when it echoes back the value of y. So let's look at the size of x and the size of y. For x, we have a 1 by 3. That means one row, 3 columns. For y, we have a size of 3 by 1. 3 rows, 1 column. X is a row vector, y is a column vector. MATLAB doesn't use these names. We use the names, but MATLAB shows you that it's a vector by showing you that the size has the number 1 in it somewhere. A vector is simply a matrix, one of whose dimensions is 1. And a scalar is a vector. It's a matrix, both of whose dimensions are equal to 1. Let's look at a picture from the book that shows the relationships among all these types of arrays. Here we see all four types, the arrays, the matrices, the vectors, and the scalars. First, we highlight the set of all arrays. This is the biggest set, and it includes all numbers of dimensions, 1, 2, 3, 4, and on and on. In particular, it includes as subsets the special types of arrays, the ones with other names. Here are the matrices. You can call these matrices or arrays, and inside the matrices are the vectors. This set includes all row vectors and all column vectors, and you can call them vectors or matrices or arrays, but we usually call them vectors. And finally, inside the set of vectors are the scalars. These are the one-by-one matrices, and you can call them scalars or vectors or matrices or arrays, but we usually just call them numbers. Everything that MATLAB works with, from the largest to the smallest, is found in this diagram. And on the subject of size, now we're going to see how you can create a very long vector without a lot of typing by using the colon operator.